Hey chocolate friends, Carla here with Opening Chocolate, and today we are going to be doing a little bit of botany. I had a friend contact me who also does chocolate tastings, and she was reading about chocolate seeds and chocolate pods, and she asked me about a term that she had never heard before, and it is a botanical term. And so I said, yes, that is, and I'll explain it to you. But at the time, I didn't have time to write a big long thing for her to read, so I said, okay, I'll make a video for everybody. So today we're going to talk botany. We're going to talk more anatomy about a cocoa pod and a cocoa seed. Okay, so let's talk about the pod. What kind of fruit is this botanically? So we're going to cut this open in half, and I'm going to show you a drawing that my daughter actually made for me, and we'll talk about the parts. But you will hear some people say that it's a drupe. I personally don't like calling it a drupe because it misses specific characteristics that a drupe has. So other fruits that you would know that are drupes are things that would be called stone fruits. Peaches, apricots, think of that hard pit in the middle. What characterizes a drupe is a fleshy mesocarp and a hard exocarp, which I'll talk about what that means later. But basically, it's the pit in the middle, which cacao pods don't have. Lots of people will call it berry-like or berry. Berry is pretty good. Berry is better than drupe, I think. A berry is a single fruit having seeds and a fleshy pulp developed from the ovary of a single flower. This is all true, except for the fleshy pulp. So that's kind of flexible. These terms come from which part of the flower develops into which part of the fruit. So I like berry better than fruit, but I like another term, bacate-like, which is berry, or bacate, which means berry-like. So it's like a berry, but not quite a berry. Think of, so other things that are a berry, a blueberry is a berry, a grape is a berry, raspberries are not berries, strawberries are not berries, bananas are berries. So botanically it can be a little weird when you mix up botanical terms with colloquial uses. So I like to say bacate, which means berry-like. So it doesn't exactly fit into the category, but it's close. So let's take a look at the cross section. So I'm gonna, if you can imagine the fruit cut this way, and then I'm gonna break it open so you're looking at the face of the fruit. So here we go. The outside part of a fruit, or the part that develops from the ovary wall, is called a pericarp. It's made up of three possible parts. The exocarp, which in a cacao pod is the hard, thick skin on the outside, which is often very colorful. That's the exocarp, exo meaning outside. The mesocarp is the next layer. It's a fleshy, meso meaning middle part. And then you have the endocarp, which is sometimes hard to distinguish, but sometimes if you look, you'll see a little line that goes all the way around close to the middle. And that is where the mesocarp would end and the endocarp would begin. So that all develops from the ovary wall of a single flower. Then inside of that, you have several seeds that have developed from ovules. The seeds are not beans, botanically speaking, they are seeds. They are attached to a stalk that runs through the middle of the pod called a placenta. Each seed which developed from an ovule is attached to that placenta by something called a funicle. And each seed is surrounded by what we would call a mucilaginous pulp, which you've probably tasted or may know about. That is, it's what's called an aril. So it's basically there to make the seed attractive to animals that would eat and transport the seed. It's there to keep water around the seed as it's planted. You may have also seen an aril around chia seeds. So if you've ever made a chia seed pudding, you know they come, they dry, you add liquid, and they get that gooey white part around the outside, and that's also an aril. So that's the part of the pod. So now let's come to the question that Barb at Cacao Chaser asked me. She said, I heard this term dicotyledon. Is that what a cocoa bean is? And the short answer is yes. So botanists use kind of this loose system of classifying flowering plants into two groups, what's called dicots and monocots. And there's several characteristics that group plants in this way, but one of them has to do with the characteristics of their seeds. So a cocoa bean is a dicot, and a cotyledon is a embryonic leaf inside the seed that are the first leaves to appear when the seed germinates. Basically, they're storage for the plant, storage of energy until it can start photosynthesizing. So I'll put, what I'm going to do is I'm going to show you a picture of a cacao, or a drawing, it's not a picture, a drawing of a cacao seed. We'll talk about the parts, and then I'm going to show you the same parts on other plants, seeds, beans, that you may be more familiar with, so that you can relate them to the cocoa seed. So here's a picture of a cocoa seed removed from a pod. Not a picture, a drawing. Sorry, I gotta keep these straight. So what this is, you see the white mucilaginous part around the outside. That's an aril, or in industry they would call it pulp. On the inside, you have the seed. Now, around the outside of the seed, you know this is the part that we winnow off. It's called the seed coat. That is, or a testa sometime if you want to be really super correct. Inside, then you have the radicle. The radicle is the part that gets hard when you roast the bean, and you have to remove it because it's really hard. The radicle is part of the seed embryo that becomes the root. The first thing a seed needs to do is get water. That's priority number one. So that little radicle grows out to get water. So the second thing it needs to do is it needs to send up a shoot so that it can start photosynthesizing and make itself energy. So that's what the rest of the seed is basically. It's made up of, in dicots or dicotyledons, 2 cotyledons. Now these are not as easy to see in cacao seeds because there's not a beautiful dividing line. We have all those little crenulations that show up that make it harder to see. But there are technically 2 parts of the seed. These are the 2 cotyledons. They're the 2 embryonic leaves that will come out, and they store and provide energy for the plant until it can produce leaves that can photosynthesize. So that's why they're full of that lovely cocoa butter, because fat has a lot of energy in it. And that is what the plant needs to get that shoot up there to make leaves so that it can start photosynthesizing. What I'm going to do is I'm going to flip the camera around and I'm going to show you these parts on some other things that you'll be familiar with so that you can see them and you can relate to the cocoa bean, because some of the things are hard to see in the cocoa bean. Okay, so let's do that. Okay, so here we've got some examples of dicotyledons and monocotyledons. I'm going to show you the cotyledons in these because you're probably more familiar with them already. And then you can relate it back to the cocoa seed. So I've got edamame, green peas, peanuts, and this is a monocot, this is corn. So let me show you on a pea first a few things. All right, so on a pea, at my dry skin. Utah winter. All right, so here is a little area that is basically a tiny hole called the hilum where the seed will suck up water so that it will know it's time to grow. Then if you look right here, you can see this is the radicle. When I pop the seed coat off, you'll see that much more clearly. So like a cocoa bean, it has a seed coat. That's what we winnow off when we're doing. So if you've ever played with your food, you already know that a pea looks like this. Whew. It's hard to do that under the camera. So I will do it off camera. Okay, so there goes one. I've taken off the seed coat, and here you can see the radicle. This is where the root's going to grow from. And then you know that green peas split into two parts. And each one of these is a cotyledon. So I don't know that I can get any closer with my iPhone, but here you see this is one cotyledon, this is a second cotyledon, this is the radicle, and this would be the embryonic shoot. So that's where the shoot comes from. This is where the root comes from. And while it is growing, before it can photosynthesize, it sucks energy in the form of sugar and fat out of the cotyledons. So you know that peas look like this. So two cotyledons, dicotyledons. Here in edamame, you can see the same thing. So they have the hilum. Here's the radicle. And let me just slice it open so we can see the seed coat and the cotyledons. Okay, so I've got pulled off the seed coat of the edamame. This is what you would winnow off in the process of making chocolate. And again, you have the radicle. And then if we split it open, we can see again we have two cotyledons. There we go. All right, two cotyledons, 1, 2, the radicle that becomes the shoot, and the tiny part. Ooh, this is hard to do because I'm used to doing it backwards on a microscope, but it's not backwards under the iPhone. Here's what will become the shoot. So again, two cotyledons, two dicots. This is what also a cocoa bean has. So again, here we look at a peanut, we take the seed coat off, and inside a peanut, sometimes people call it the Santa Claus, you have two cotyledons, and then you've got the radicle, and here these little Santa's beard are teeny tiny little leaves that will become the shoot. So two cotyledons, radicle, and what will become the shoot. So this is the same thing, the same parts that are in a cocoa seed. So a cocoa seed will have the radicle. A cocoa seed will have two dicotyledons, although they're not quite as nicely clear cut as they are in these examples, but that's why I'm showing you these examples. And then they also have the part that will develop into the shoot. So here is what a monocot looks like. All right, so a monocot is, corn is an example of a monocot. Grasses are all monocots. So if we were to, again, this is hard to do, not under a microscope. If I were to cut it, so this part right here, again, would be the radicle, and the whole kernel would be the one cotyledon. Let's see if I can tease out the little leaves. So I've longitudinally sectioned it, so I've cut it down here, and you're looking at it open, and you can see here, here's the radicle, and then there would be tiny embryonic leaves up there that would grow into the shoot. So this one, you know, corn doesn't break into two nice halves like a pea or edamame or a peanut. It's just got one cotyledon. So that is what a cotyledon is, Barb. That was a long explanation, but I wanted to make sure that you understood because it's not clear in a cacao seed with all those crenulations. So I'm going to flip the camera back around and I'm going to show you one more thing. Okay, that was probably more botany than you ever wanted to know, but now you have my permission to go play with your food. Any bean is going to be like that. Peas, any legume, you're going to be able to see it quite easily, the two dicotyledons. But this happens in, like I said, all flowering plants are either divided into monocots or dicots. And you'll see that in all of the seeds. So go play with your food, check some stuff out, and see if you can relate it back to what you see in the cocoa seeds. Now, I just want to talk a little bit about germination. So here is a drawing of what happens when a seed is exposed to water and is preparing to germinate. So what happens is that really tough radical that we normally sieve out when we're making chocolate, that becomes the root. So it will, when it recognizes that there's water there, it sends out the root, and it has a root meristem, which is where cells are created, and then it's got a part where the cells get bigger. It's called the zone of elongation, and then it has a part where little tiny roots start popping out, and that's called the zone of differentiation. And then it normally hooks back in to the seed, and then the shoot will kind of come up from where that hook is. So that area where it's hooking back into the seed is called the hypocotyl, which means between the root and the cotyledon. So the cotyledon is the energy source that the plant is using to make all of these cells. So basically all the root is doing is sucking up water. It's just getting water, 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 because you can't do anything without water. The cotyledon is providing energy in the form of fat and sugar, and when it gets its shoot up and it can produce the real leaves, then those cotyledons will shrink and shrivel, and because all of their contents have been used to produce the plant. And sometimes you'll still see them on the tiny plants. Any plant that you grow, you can, from seed, you will often see the cotyledons shriveled up close to the base of the plant until they fall off. So, long story short, Barb, this one was for you. I hope that clarified what a cotyledon is, and that cocoa seeds do have technically two cotyledons, although they're a little bit hard to distinguish, and that is a correct botanical terminology to use in a cocoa seed. So that was probably way more botany than you want to know. Introduction to Botany 101. Yeah, that was a lot. If you're just interested in chocolate, I hope you found it interesting. I hope you go play with your food, explore botany. Botany's amazing. Plants are amazing. Chocolate is awesome. The Cacao Pod doesn't fit into all the categories perfectly, but it is a beautiful plant with so many interesting things about it, and we get delicious chocolate out of it. So if you have any questions, you want to ask me clarity about botany terms with regard to the cocoa plant, drop it in the comments below and let me know, and make sure to subscribe so that you will get more chocolate cocoa content in your feed, and I will see you next time. Thanks for watching.